So let's check our work from example 5. I'm hoping that you not only showed this notation, but got the correct answer. You moved the 5 to the outside, and then said 5 times 3 is 15 for a limit of 15. I want to see limit notation in 5b that looks like this. You bring your 6 down. We know that this limit is 2. We know that this limit is 3 for a final answer of 8/3. Again, one of the most important things that you can remember is that when we do a limit, our first thing we should always try is direct substitution. That's probably one of the most important things for you to know. So I see this limit right here. First thing I'm going to do is direct sub. 3, 2 squared minus 5 times 2 plus 1 is a value of 3. Guys, that's your limit. You'll also notice I didn't write the words limit right here because when you direct sub, you no longer need the limit notation. 6b, again, I'm going to sub in 5. I'm going to say cosine of 5 pi 6. And because I know all of my unit circle from pre-cal, I'm going to get negative root 3 over 2. Again, direct substitution worked for us. In example 6c, I'm going to plug in pi fourths. And again, because I know my trig really well from pre-cal, I'm going to write tangent of 7 pi fourths. And because I'm direct substituting, I'm not writing the word limit, and I'm going to get the value of negative 1. So remember, direct substitution is a fantastic tool to get us to our limit. But there's going to be moments where you can't get a limit. So if you cannot evaluate the limit using direct substitution, we're going to learn some algebraic techniques to rewrite the function so that we can evaluate the limit. If this substitution yields 0 over 0, we call this an indeterminate form, which means I can't really tell what it is. 0 over 0 is not 0. So it's a form that we don't really know what's going on. And that's a phrase you're going to hear several times this year. And there's other indeterminate forms that we'll talk about later in the year, but we're not going to get there yet. So number 1, we've already talked about using a tabular method. We're on to our second method, this is actually our third method because we did tabular and graphical. So third method is our analytical. And that basically means we're going to use algebra. Now, pay careful attention to notation that I'm about to use. So what I would always recommend that you do is that you should start by plugging in, but don't plug in on paper, plug in your brain. So if I plug in, I can clearly see that the bottom gives me 0. And if I plug in the top, I get 9 minus 3 is 6, 6 minus 6 is 0. So AP Calculus requires that you do the following. We're going to write top, and I'm going to write the limit as x approaches negative 3 of x squared plus x minus 6. And I'm going to say that that's 0. Okay, so that is our top limit. We're now going to write the word bottom. And we're going to show the limit as x approaches negative 3 of x plus 3 is also 0. So it is really important for the AP exam that you represent those as 2 separate limits before you do what we're about to do. Okay? So we're showing that this is an indeterminate form, 0 divided by 0. So now here's where our algebra comes in. Trick number 1 is called factor cancel. So we're going to have excellent algebra skills. So I'm going to write limit as x approaches negative 3. And I'm going to factor the top into x plus 3 and x minus 2. And I'm going to have x plus 3. Now what I'm saying is these 2 limits are equivalent. And I want you to get really good at stringing your work together with equal signs for the AP exam. So from Algebra 2, we learned that when you have a factor on the top and a factor on the bottom that matches, they can be reduced to 1. And so now we're going to say that this limit is equivalent to just this. So we're saying this limit is equivalent to this limit is equivalent to this limit, and now we've eliminated the problem, and I can direct substitute. -3 minus 2 is -5, and -5 is my limit. Now, connecting this back to what you know from Algebra 2. Guys, this happens to be, if you were to go graph this, this would be a value at, I have a y-intercept of -2 and a slope of 1, and you'd have a linear function. But here's what's cool about this linear function. This linear function happens to have a hole. I should have extended it out just a little bit more. This is that linear function that you guys saw in Algebra 2 and Pre-Cal that has a hole in the graph. And guess where that hole is located? It's at -3, -5. That's the y value of the hole. So we're using and connecting skills from previous classes. So notice I stopped writing limit right here because at the minute you direct substitute, you don't write the word limit anymore. Let's do it again. Let's do some more. So we're looking at 7b, and I see in my brain, I'm going to plug these in my head. I see the bottom is going to give me 4 minus 4, which is 0. The top is going to give me 4 minus 3, which is 1. Square root of 1 is 1, and I get 0 on the top. So that means I'm going to go out to the side. I'm going to say top limit as x approaches 4 of square root of x minus 3 minus 1. And I'm going to tell my reader that that is 0. And we're going to say bottom limit as x approaches 4 of the function x minus 4 is also 0. And so now we're going to need another trick. Algebra trick number 2 is called use conjugates. And a pretty dead giveaway that we're going to use conjugates is when you see square roots. So here's what we're about to do. I'm going to keep this x minus 3 minus 1 and this x minus 4, but we're going to multiply by something. I'm going to multiply by the square root of x minus 3 plus 1 and the square root of x minus 3 plus 1. And I can do that because that's just a form of 1, okay? So here we go. We're going to multiply. Root x minus 3 times root x minus 3 is just going to give me x minus 3. And root x minus 3 times positive 1 is going to be plus the root x minus 3. And that's going to give me minus root x minus 3. And the -1 times positive 1 is -1. In the denominator, here is what's important. In your denominator, I want you to not distribute. I want you to leave it x minus 4 and x minus 3 plus 1. So that's going to be super important. Do not distribute the denominator out. Now this looks gross, but here's what's about to happen. First thing is that this and this go away. If I now simplify these, limit as x approaches 4, I have x minus 3 minus 1, which happens to give me x minus 4. And here, guys, is why I told you do not multiply out your bottom when we use conjugates, because these reduce away to a form of 1. I get the limit as x approaches 4 of 1 over radical x minus 3 plus 1, and I can direct substitute. 1 over the radical of 4 minus 3 plus 1, and I get a value of 1/2, which is super nice. So method number 1, factor cancel. Method number 2, use conjugates. Let's see method number 3. So method number 3, we're going to go in here and we're going to plug in first. We're going to direct substitute. So I direct substitute. I can clearly see that the bottom is 0, and I can see that the top will give me 1/2 minus 1/2, which is 0. Again, I am expecting to see top limit. Limit as x approaches 0, 1 over x plus 2 minus 1/2, and I'm going to say that's 0. And I'm getting these values from direct substitution. And the limit as x approaches 0 of x is 0 for my bottom. So I've got top, I've got bottom. So method number 3 is going to be common denominators. Common denominators. So what we're going to do is we're going to take this thing right here and we're going to make it have common denominators. So to do that, let's actually go out to the side and do some side work and remember some things from Algebra 2. So a common denominator is clearly going to have to be 2 and x plus 2 and 2 and x plus 2. Okay? So that means this guy gets multiplied by 2 on the top and the bottom. And this guy gets multiplied by an x plus 2 on the top and on the bottom. Okay, so we're going to get 2 minus x plus 2. So going over here, we have the limit as x approaches 0 of 2 minus x plus 2 over 2x plus 2. Now what you can't forget is that there's still this over x over here. Okay, so you got to be really, really, really good with figuring out this common denominator and keeping all the pieces with your algebra correct. So what we're going to do next, notice I'm writing limit every step until we direct substitute. I'm going to turn this into 2 minus x, distributing that negative, minus 2 over 2x plus 2. And then for this piece, remember that this is x over 1. And dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm just changing this to 1 over x. Notice how I'm stringing my work together with equal signs. So now we have the limit as x approaches 0. My 2's are going to go away, and I have negative x. And then I have 2x plus 2. And then I've got that red x that can now actually be on the bottom here. And so what that does for me is I'm going to get rid of this x and this x. They're going to reduce away to 1. And this thing is now equivalent to the limit as x approaches 0 of negative 1 over 2x plus 2. Now that was a lot of algebra, but what we just did is I can now plug in my 0. I drop the limit because I'm direct substituting and get negative 1/4. Okay? So here's where we're at. We've got a couple more examples where we're going to factor cancel. What I will remind you of is you guys are actually going to need to remember your sum and difference of cube formulas from Algebra 2. So sum of cubes factors into a plus b, a squared minus ab plus b squared, and the difference of cubes factors into a minus b, a squared plus ab plus b squared. And if you were in my class, I taught the SOAP acronym, and that was for same sign, opposite sign, always positive. Same sign, opposite sign, always positive. So we dive into this first example, and I'm going to start by plugging in the top. I'm going to find the limit as x approaches 3 of x cubed minus 27, and I'm going to get 0. And I'm going to find my bottom limit as, and I'm going to run out of room, so let's go over here. Bottom limit as x approaches 3 of x minus 3 is also going to be 0. So that tells me I need to do some work. So remember, the 3 tools in our toolbox are factor cancel, conjugates, and common denominators. So I'm going to try the factor cancel business here. We're going to factor the top. String your work together with equal signs. I'm going to use sum and difference of cubes. So this is going to become x minus 3, x squared plus 3x plus 9. And my denominator stays x minus 3. And this is fortuitous because my x minus 3's reduce away to 1. And I have x squared plus 3x plus 9 remaining, which means I can now direct substitute. 3 squared plus 3 times 3 plus 9 and get a value of 27. And so I'm going to actually ask for you guys now to try 7e on your own. My hint is you're going to have to factor cancel. So I will ask you to try this one on your own. And you should know that you got the right answer if you get -6, but pay careful attention to your notation. And so press pause on the video, and I will see you in a minute. So what I'm looking for in this problem, I'm looking for you to have gotten the limit as x approaches -4, and for you to show x cubed plus 64 is 0. And I'm also looking for a bottom limit as x approaches -4 of x squared minus 16 is also 0. So showing those two things, very important. Once you've showed those two things, then you can go into your factoring work. I've got a sum of cubes in the top, so x plus 4, x squared minus 4x plus 16. The bottom is my difference of squares, algebra skills, and then I can reduce away my common factors, tell my grader what this is now equivalent to, and I should be in a situation where I can now direct substitute. -4 squared minus 4 times -4 plus 16 all over -4 minus 4 for a grand total of -6. For time purposes, I'm going to skip 7F and we will pick back up in a moment.